Australian Information Security Manual. In audiobook format. Please subscribe and like for more content. This part of the audiobook will cover the following sections. Part 11. Let's begin. Guidelines for System Management. System Administration. System Administration of Cloud Services. System administration of cloud services brings unique challenges when compared to system administration of on-premises assets. Notably, responsibility for system administration of cloud services is often shared between service providers and their customers. As the system administration processes and procedures implemented by service providers are often opaque to their customers, customers should consider a service provider's control plane to operate within a different security domain. System administration processes and procedures. A key component of system administration is ensuring that administrative activities are undertaken in a repeatable and accountable manner using system administration processes and procedures. In doing so, requirements for administrative activities may cover configuring applications, operating systems, network devices or other ICT equipment, applying patches, updates or vendor mitigations to applications, drivers, operating systems or firmware, installing or removing applications, operating systems, network devices or other ICT equipment, implementing system changes or enhancements, resolving problems identified by users. Furthermore, in support of change management processes and procedures, system administrators should document requirements for administrative activities, consider potential security impacts, obtain any necessary approvals, notify users of any disruptions or outages, and maintain system and security documentation. Security control. System administration processes, and supporting system administration procedures, are developed and implemented. Security control. System administrators document requirements for administrative activities, consider potential security impacts, obtain any necessary approvals, notify users of any disruptions or outages, and maintain system and security documentation. Separate privileged operating environments. One of the greatest threats to the security of networks is the compromise of privileged accounts. Providing a separate privileged operating environment for system administrators, in addition to their unprivileged operating environment, makes it much harder for administrative activities and privileged accounts to be compromised by an adversary. Using different physical workstations is the most secure approach to separating privileged and unprivileged operating environments for system administrators. However, a virtualization-based solution may be sufficient for separating privileged and unprivileged operating environments. In such cases, privileged operating environments should not be virtualized within unprivileged operating environments. Security control. Administrative infrastructure is segregated from the wider network. Security control. Administrative infrastructure for critical servers, high-value servers and regular servers is segregated from each other. Security control. Network management traffic can only originate from administrative infrastructure. Security control. Only privileged operating environments can communicate with jump servers. Security control. Only jump servers can communicate with assets requiring administrative activities to be performed. System patching. Patch management processes and procedures. Applying patches or updates is critical to ensuring the ongoing security of applications, drivers, operating systems and firmware. In doing so, it is important that patches or updates are applied consistently and in a secure manner. For example, by using a centralized and managed approach that maintains the integrity of patches or updates, and confirms that they have been applied successfully. Security control. Patch management processes, and supporting patch management procedures, are developed and implemented. Security control. A centralized and managed approach that maintains the integrity of patches or updates, and confirms that they have been applied successfully, is used to patch or update applications, operating systems, drivers and firmware. Software register. To assist with monitoring information sources for details of relevant patches or updates, an organization should maintain and regularly verify software registers for workstations, servers, network devices and other ICT equipment. Security control. Software registers are maintained for workstations, servers, network devices and other ICT equipment and verified on a regular basis. Security control. Software registers contain versions and patch histories of applications, drivers, operating systems and firmware. When to patch security vulnerabilities. When patches or updates are released by vendors for security vulnerabilities, an organization should apply them in a timeframe commensurate with the likelihood of attempted exploitation by an adversary. For example, By prioritizing patches or updates for security vulnerabilities in internet-facing services and their operating systems, especially when exploitation code exists or active exploitation is occurring. If no patches or updates are available for security vulnerabilities, mitigation advice from vendors, trusted authorities or security researchers may provide some protection until patches or updates are made available. Such mitigation advice may be published in conjunction with, or soon after, announcements made relating to security vulnerabilities. Mitigation advice may cover how to disable or block access to vulnerable functionality, how to reconfigure vulnerable functionality, or how to detect attempted or successful exploitation of vulnerable functionality. If a patch or update is released for high-assurance ICT equipment, the ACSC will conduct an assessment of the patch or update. Subsequently, if the patch or update is approved for deployment, the ACSC will provide guidance on the methods and timeframes in which it is to be applied. Security control. Patches, updates or vendor mitigations for security vulnerabilities in operating systems of other ICT equipment are applied within 2 weeks of release, or within 48 hours if an exploit exists. Security control. Patches, updates or vendor mitigations for security vulnerabilities in drivers and firmware are applied within 2 weeks of release, or within 48 hours if an exploit exists. Security control. Patches, updates or vendor mitigations for security vulnerabilities in high-assurance ICT equipment are applied only when approved by the ACSC, and in doing so, using methods and timeframes prescribed by the ACSC. Scanning for missing patches or updates. To ensure that patches or updates have been applied to applications, operating systems, drivers and firmware, it is essential that an organization scan for missing patches or updates on a regular basis using a vulnerability scanner, preferably in an automated manner. Ideally, vulnerability scanning should take place at half the frequency in which patches or updates need to be applied. For example, if patches or updates are applied fortnightly, then vulnerability scanning should be undertaken weekly. Security control. A vulnerability scanner is used at least weekly to identify missing patches for security vulnerabilities in operating systems of other ICT equipment. Security control. A vulnerability scanner is used at least weekly to identify missing patches for security vulnerabilities in drivers and firmware. Cessation of support. When applications, operating systems, network devices and other ICT equipment reach their cessation date for support, an organization will find it increasingly difficult to protect them against security vulnerabilities as patches, updates and other forms of support will no longer be made available by vendors. As such, unsupported applications, operating systems, network devices and other ICT equipment should be removed or replaced. In planning for such activities, it is important to note that while vendors generally advise the cessation date for support of operating systems well in advance, some applications, network devices and other ICT equipment may cease to receive support immediately after newer versions are released. Security control. Network devices and other ICT equipment that are no longer supported by vendors are replaced. Data backup and restoration. Digital preservation policy. Developing and implementing a digital preservation policy, as part of digital continuity planning, can assist in ensuring the long-term integrity and availability of important data is maintained, especially when taking into account the potential for data degradation and removable media, hardware and software obsolescence. Security control. A digital preservation policy is developed and implemented. Data backup and restoration processes and procedures. Having data backup and restoration processes and procedures is an important part of business continuity and disaster recovery planning. Such activities will also form an integral part of an overarching digital preservation policy. Security control. Data backup processes, and supporting data backup procedures, are developed and implemented. Security control. Data restoration processes, and supporting data restoration procedures, are developed and implemented. Performing and retaining backups. When performing backups, all important data, software and configuration settings should be captured in a coordinated and resilient manner on a regular basis in accordance with business continuity requirements. This will ensure that should a system fall victim to a ransomware attack, important data will not be lost and, if necessary, systems can be quickly restored. Security control. An event logging policy is developed and implemented. Event log details. For each event logged, sufficient detail needs to be recorded in order for the event log to be useful. Security control. For each event logged, the date and time of the event, the relevant user or process, the relevant file name, the event description, and the ICT equipment involved are recorded. Event logging facility. A centralized event logging facility can be used to manage event logs from multiple sources in a coordinated manner. This may be achieved by using a security information and event management solution. Furthermore, in support of a centralized event logging facility, it is important that an accurate time source is established and used consistently across systems to assist with identifying connections between events. Security control. A centralized event logging facility is implemented and systems are configured to save event logs to the facility as soon as possible after each event occurs. Security control. An accurate time source is established and used consistently across systems to assist with identifying connections between events. Event log monitoring. Event log monitoring is critical to maintaining the security posture of systems. Notably, such activities involve analyzing event logs in a timely manner to detect cybersecurity events, thereby leading to the identification of cybersecurity incidents. Security control. Event logs are analyzed in a timely manner to detect cybersecurity events. Security control. Cybersecurity events are analyzed in a timely manner to identify cybersecurity incidents. Event log retention. As event logs are integral to event log monitoring activities, they should be retained for the life of systems, potentially longer. However, the minimum retention period required under the National Archives of Australia's Administrative Functions Disposal Authority Express version 2 publication is 7 years. Security control. Event logs are retained for a minimum of 7 years in accordance with the National Archives of Australia's Administrative Functions Disposal Authority Express version 2 publication. Security control. Domain name system and web proxy event logs are retained for at least 18 months. Guidelines for software development. Application development. Types of application development. These guidelines are applicable to both traditional application development and mobile application development. Development, testing and production environments. Segregating development, testing and production environments, and associated data, can limit the spread of malicious code and minimizes the likelihood of faulty code being introduced into a production environment. Furthermore, protecting the authoritative source for software is critical to preventing malicious code being surreptitiously introduced into software. Security control. Development, testing and production environments are segregated. Security control. Development and modification of software only takes place in development environments. Security control. Data from production environments is not used in a development or testing environment unless the environment is secured to the same level as the production environment. Security control. Unauthorized access to the authoritative source for software is prevented. Secure software design and development. Secure by design principles and secure programming practices, supported by threat modeling, are an important part of application development as they can assist with the identification and mitigation of at-risk software components and risky programming practices. Security control. Secure by design principles and secure programming practices are used as part of application development. Security control. Threat modeling is used in support of application development. Software bill of materials. A software bill of materials is a list of open source and commercial software components used in application development. This can assist in providing greater cyber supply chain transparency for consumers by allowing for easier identification and management of security risks associated with individual software components used by applications. Security control. A software bill of materials is produced and made available to consumers of software. Application testing and maintenance. Application testing and maintenance activities can lessen the likelihood of security vulnerabilities in applications being introduced into a production environment. Robust application testing can be performed using both static testing, such as code analysis, as well as dynamic testing, such as input validation and fuzzing. Vulnerability scanning tools can also assist in the detection of known security vulnerabilities, such as out-of-date or vulnerable software components. Using an independent party for application testing will remove any bias that can occur when a software developer tests their own applications. Security control. Applications are robustly tested for security vulnerabilities by software developers, as well as independent parties, prior to their initial release and following any maintenance activities. Security control. Security vulnerabilities identified in applications are resolved by software developers. Vulnerability Disclosure Program. Implementing a vulnerability disclosure program, based on responsible disclosure, can assist an organization to improve the security of their products and services as it provides a way for security researchers and other members of the public to responsibly notify them of security vulnerabilities in a coordinated manner. Furthermore, following the verification and resolution of reported security vulnerabilities, it can assist an organization in notifying their customers of security vulnerabilities that have been discovered in their products and services, and any patches, updates or vendor mitigations that should be applied. A vulnerability disclosure program should include processes and procedures for receiving, verifying, resolving and reporting security vulnerabilities disclosed by both internal and external parties. In support of this, a vulnerability disclosure policy should be made publicly available that covers the purpose of the vulnerability disclosure program, types of security research that are and are not allowed, how to report any security vulnerabilities, actions, and associated timeframes upon notification of security vulnerabilities, expectations regarding the public disclosure of security vulnerabilities, any recognition or reward for finders of security vulnerabilities. Finally, the Australian Cyber Security Centre, ACSC, encourages security researchers and other members of the public to responsibly report security vulnerabilities directly to an organization. However, the ACSC recognizes that this is not always practical. Initial attempts at communication may be unsuccessful or the person making the report may not wish to do so directly. In such cases, security vulnerabilities can be reported to the ACSC as an independent coordinator. Security control. A vulnerability disclosure program is implemented to assist with the secure development and maintenance of products and services. Security control. A vulnerability disclosure policy is developed and implemented. Security control. Vulnerability disclosure processes, and supporting vulnerability disclosure procedures, are developed and implemented. Security control. A security.txt file is hosted for all Internet-facing organizational domains to assist in the responsible disclosure of security vulnerabilities in an organization's products and services. Web application development. Open Web Application Security Project. The Open Web Application Security Project, OWASP, provides comprehensive resources for software developers that should be followed when developing web applications. Security control. The OWASP Application Security Verification Standard is followed when developing web applications. Web application frameworks. Web application frameworks can be leveraged by software developers to enhance the security of web applications while decreasing development time. These resources can assist in securely implementing complex software functions, such as session management, input handling and cryptographic operations. Security control. Robust web application frameworks are used in the development of web applications. Web application interactions. Hypertext Transfer Protocol Secure, HTTPS, is the Hypertext Transfer Protocol Secure by Transport Layer Security, TLS, encryption. The use of HTTPS for web applications ensures that not only are interactions with web applications confidential, but the integrity of interactions are also maintained. Security control. All web application content is offered exclusively using HTTPS. Web application input handling. Most web application security vulnerabilities are caused by a lack of secure input handling. As such, it is essential that web applications do not trust any input, such as website addresses and their parameters, hypertext markup language, HTML, form data, cookie values, or request headers, without performing validation or sanitization. Examples of validation and sanitization include ensuring a telephone form field contains only numerals, ensuring data used in a structured query language query is sanitized properly, and ensuring Unicode input is handled appropriately. Security control. Validation or sanitization is performed on all input handled by web applications. Web application output encoding. The likelihood of cross-site scripting and other content injection attacks can be reduced through the use of output encoding. In particular, output encoding is useful when external data sources, which may not be subject to the same level of input filtering, are output to users. The most common example of output encoding is the conversion of potentially dangerous HTML characters into their encoded equivalents, such as less than comma and an into an LT, and GT, and an AMP. Security control. Output encoding is performed on all output produced by web applications. Web browser-based security controls. Web browser-based security controls, such as Content Security Policy, Hypertext Transfer Protocol Strict Transport Security, HSTS, and X-Frame options, can be used by web applications to help protect themselves and their users. This is achieved via setting security policy and response headers from web applications which web browsers then apply. Note, since the security controls are applied via response headers, they can be applied to legacy or proprietary web applications where changes to their source code may be impractical. Security control. Web applications implement Content Security Policy, HSTS and X-Frame options via security policy and response headers. Web application event logging. Certain web application events can assist in monitoring the security posture of web applications, detecting malicious behavior and contributing to investigations following cybersecurity incidents. In doing so, web application event logs should be centrally stored and protected from unauthorized modification and deletion, monitored for signs of compromise, and actioned when cybersecurity events are detected. Security control. The following events are logged for web applications: attempted access that is denied, crashes and error messages, and search queries initiated by users. Security control. Web application event logs are centrally stored and protected from unauthorized modification and deletion, monitored for signs of compromise, and actioned when cybersecurity events are detected. Guidelines for database systems. Database servers. Functional separation between database servers and web servers. Due to the higher threat environment that web servers are typically exposed to, hosting database servers and web servers within the same operating environment increases the likelihood of database servers being compromised by an adversary. This security risk can be mitigated by ensuring that database servers are functionally separated from web servers. Security control. Database servers and web servers are functionally separated. Communications between database servers and web servers. Data communicated between database servers and web servers, especially over the Internet, is susceptible to capture by an adversary. As such, it is important that all data communicated between database servers and web servers is encrypted. Security control. Data communicated between database servers and web servers is encrypted. Network environment. Placing database servers on the same network segment as user workstations can increase the likelihood of database servers being compromised by an adversary. Additionally, in cases where databases will only be accessed from their own database server, allowing remote access to the database server poses an unnecessary security risk. Security control. Database servers are placed on a different network segment to user workstations. Security control. Network access controls are implemented to restrict database server communications to strictly defined network resources, such as web servers, application servers and storage area networks. Security control. If only local access to a database is required, networking functionality of Database Management System, DBMS, software is disabled or directed to listen solely to the local host interface. Separation of development, testing and production database servers. Using production database servers for development and testing activities could result in accidental damage to their integrity or contents. Security control. Development and testing environments do not use the same database servers as production environments. Database Management System software. Temporary installation files and logs. DBMS software will often leave behind temporary installation files and logs during the installation process in case a database administrator needs to troubleshoot a failed installation. These files, which can include credentials, could be valuable to an adversary. Security control. All temporary installation files and logs are removed after DBMS software has been installed. Hardening and configuration. Poorly configured DBMS software could provide an opportunity for an adversary to gain unauthorized access to database contents. To assist an organization in deploying DBMS software, vendors often provide guidance on how to securely configure their products. Security control. DBMS software is configured according to vendor guidance. Security control. Unneeded accounts, components, services and functionality of DBMS software are disabled or removed. Restricting privileges. If DBMS software operating as a local administrator or root account is compromised by an adversary, it can present a significant security risk to the underlying database server. In addition, DBMS software is often capable of accessing files that it has read access to on the database server. For example, an adversary performing a structured query language, SQL, injection attack could use the command load data local infile etc/password into table users, or select load_file/etc/password, to access the contents of a Linux password file. Disabling the ability of the DBMS software to read local files from its database server will prevent such SQL injection attacks from succeeding. Security control. DBMS software is configured to run as a separate account with the minimum privileges needed to perform its functions. Security control. The account under which DBMS software runs has limited access to non-essential areas of the database server's file system. Security control. The ability of DBMS software to read local files from its database server is disabled. Database administrator accounts. DBMS software often comes pre-configured with default database administrator accounts and credentials that are listed in vendor documentation. These default database administrator accounts should be disabled, renamed, or have their credentials changed. When sharing database administrator accounts for the performance of administrative activities, any actions undertaken will not be attributable to an individual database administrator. This can hinder investigations relating to an attempted or successful intrusion. Furthermore, database administrator accounts shared across different databases can exacerbate any compromise of a database administrator account by an adversary. When creating new database administrator accounts are often allocated all privileges available to system administrators. However, most database administrators will only require a subset of all available privileges to undertake their duties. Security control. Default database administrator accounts are disabled, renamed, or have their credentials changed. Security control. Database administrators have unique and identifiable accounts. Security control. Database administrator accounts are not shared across different databases. Security control. Database administrator accounts are used exclusively for administrative activities, with standard database accounts used for general-purpose interactions with databases. Security control. Database administrator access is restricted to defined roles rather than accounts with default administrative permissions or all permissions. Databases. Database register. Without knowledge of all the databases in an organization, and their contents, an organization will be unable to appropriately protect their assets. Security control. A database register is maintained and verified on a regular basis. Protecting databases. Databases can be protected from unauthorized copying and subsequent offline analysis by applying file-based access controls to database files. Security control. File-based access controls are applied to database files. Protecting database contents. Database administrators and database users should know the sensitivity or classification associated with databases and their contents. In cases where all of a database's contents are the same sensitivity or classification, an organization should classify the entire database at this level and protect it as such. Alternatively, in cases where a database's contents are of varying sensitivities or classifications, and database users have varying levels of access to the database's contents, an organization should protect the database's contents at a more granular level. Restricting database users' ability to access, insert, modify, or remove database contents, based on their work duties, ensures that the likelihood of unauthorized access, modification, or deletion of database contents is reduced. Furthermore, where concerns exist that the aggregation of separate pieces of content from within a database could lead to an adversary determining more sensitive or classified content, the need-to-know principle can be enforced through the use of minimum privileges, database views, and database roles. Alternatively, the content of concern could be separated by implementing multiple databases, each with restricted datasets. Security control. Databases and their contents are classified based on the sensitivity or classification of data that they contain. Security control. Database users' ability to access, insert, modify, and remove database contents is restricted based on their work duties. Security control. The need-to-know principle is enforced for database contents through the application of minimum privileges, database views, and database roles. Separation of development, testing, and production databases. Using database contents from production environments and development or testing environments could result in inadequate protection being applied to the database contents. Security control. Database contents from production environments are not used in development or testing environments unless the environment is secured to the same level as the production environment. Web application interaction with databases. SQL injection attacks are a significant threat to the confidentiality, integrity, and availability of database contents. Specifically, SQL injection attacks can allow an adversary to steal database contents, modify database contents, delete an entire database, or even in some circumstances gain control of the underlying database server. Furthermore, when database queries from web applications fail, they may display detailed error information about the structure of databases. This can be used by an adversary to further tailor SQL injection attacks. Security control. All queries to databases from web applications are filtered for legitimate content and correct syntax. Security control. Parameterized queries or stored procedures are used for database interaction instead of dynamically generated queries. Security control. Web applications are designed to provide as little error information as possible about the structure of databases. Database event logging. Certain database events can assist in monitoring the security posture of databases, detecting malicious behavior, and contributing to investigations following cybersecurity incidents. In doing so, database event logs should be centrally stored and protected from unauthorized modification and deletion, monitored for signs of compromise, and actioned when cybersecurity events are detected. Security control. The following events are logged for databases: access or modification of particularly important content, addition of new users, especially privileged users, changes to user roles or database permissions, attempts to elevate privileges, any query containing comments, any query containing multiple embedded queries, any query or database alerts or failures, changes to the database structure, database administrator actions, use of executable commands, database logons and logoffs. Security control. Database event logs are centrally stored and protected from unauthorized modification and deletion, monitored for signs of compromise, and actioned when cybersecurity events are detected. Guidelines for email. Email usage. Email usage policy. As there are many security risks associated with the use of email services, it is important that an organization develops an email usage policy governing its use. Security control. An email usage policy is developed and implemented. Webmail services. When users access non-approved webmail services, they often bypass security controls that have been implemented by an organization, such as email content filtering. To mitigate this security risk, access to non-approved webmail services should be blocked. Security control. Access to non-approved webmail services is blocked. Protective markings for emails. Implementing protective markings for emails helps to prevent data spills, such as unauthorized data being released into the public domain. In doing so, it is important that protective markings reflect the highest sensitivity or classification of the subject, body and attachments of emails. Security control. Protective markings are applied to emails and reflect the highest sensitivity or classification of the subject, body and attachments. Protective marking tools. Requiring user involvement in the protective marking of emails ensures a conscious decision is made by users, thereby lessening the chance of incorrect protective markings being applied to emails. In addition, allowing users to select only protective markings for which a system is authorized to process, store or communicate lessens the chance of users inadvertently overclassifying emails. Email content filters may only check the most recent protective marking applied to emails. Therefore, when users are responding to or forwarding emails, requiring protective markings which are at least as high as that of emails that are received will help email content filters prevent emails being sent to systems that are not authorized to handle their original sensitivity or classification. Security control. Protective marking tools do not automatically insert protective markings into emails. Security control. Protective marking tools do not allow users to select protective markings that a system has not been authorized to process, store or communicate. Security control. Protective marking tools do not allow users replying to or forwarding emails to select protective markings lower than previously used. Handling emails with inappropriate, invalid or missing protective markings. It is important that email servers are configured to block emails with inappropriate protective markings. For example, blocking inbound and outbound emails with protective markings higher than the sensitivity or classification of the receiving system, as this will prevent a data spill from occurring. In doing so, it is important to inform the intended recipients of blocked inbound emails, and the senders of blocked outbound emails, that this has occurred. If emails are received with invalid or missing protective markings, they may still be passed to their intended recipients. However, the recipients will have an obligation to determine appropriate protective markings if emails are to be responded to, forwarded or printed. If unsure, original senders of emails should be contacted to provide guidance on appropriate protective markings. Security control. Email servers are configured to block, log and report emails with inappropriate protective markings. Security control. The intended recipients of blocked inbound emails, and the senders of blocked outbound emails, are notified. Email distribution lists. In some cases, the membership and nationality of members of email distribution lists will be unknown. As such, emails containing Australian eyes only, Australian government access only or releasable to data that are sent to email distribution lists could accidentally cause a data spill. Security control. Emails containing Australian eyes only, Australian government access only or releasable to data are not sent to email distribution lists unless the nationality of all members of email distribution lists can be confirmed. Email gateways and servers. Centralized email gateways. By failing to route emails via a centralized email gateway, it will be difficult for an organization to deploy Sender Policy Framework, SPF, Domain Keys Identified Mail, DKIM, Domain-Based Message Authentication, reporting and conformance, mark, and protective marking checks. Security control. Emails are routed via a centralized email gateway. Security control. When users send or receive emails, an authenticated and encrypted channel is used to route emails via their organization's centralized email gateway. Email gateway maintenance activities. As backup and alternative email gateways are often poorly maintained in terms of patches and email content filtering, an adversary will often seek to exploit this when sending malicious emails to an organization. As such, it is important that backup and alternative email gateways are maintained at the same standard as an organization's primary email gateway. Security control. Where backup or alternative email gateways are in place, they are maintained at the same standard as the primary email gateway. Open Relay email servers. An Open Relay email server, or Open Mail Relay, is an email server that is configured to allow anyone on the internet to send emails through it. Such configurations are highly undesirable as spammers and worms can exploit them. Security control. Email servers only relay emails destined for or originating from their domains. Email server transport encryption. Emails can be intercepted anywhere between originating email servers and destination email servers. Implementing opportunistic transport layer security, TLS, encryption can mitigate this security risk while ensuring email servers remain compatible with each other. However, opportunistic TLS encryption is susceptible to downgrade attacks. To mitigate this security risk, Mail Transfer Agent Strict Transport Security, MTASTS, allows domain owners to indicate that email transfers should only occur if satisfactory TLS encryption is negotiated beforehand. Implementing MTASTS reduces the opportunity for downgrade attacks during email transfers, and provides visibility of when they are attempted. TLS reporting supports the implementation of MTASTS by providing a mechanism for a domain owner to publish a location where reports can be submitted regarding the success or failure of attempts to initiate encrypted connections when sending emails to a specified domain. Security control. Opportunistic TLS encryption is enabled on email servers that make incoming or outgoing email connections over public network infrastructure. Security control. MTASTS is enabled to prevent the transfer of unencrypted emails between complying servers. Sender Policy Framework. SPF aids in the detection of spoofed emails by specifying a list of domains that are allowed to send emails. If an email server is not in the SPF record for a domain, SPF verification will fail. In specifying SPF records, domain owners should ensure that they delegate the minimum necessary set of hosts or Internet Protocol addresses necessary for sending emails. In addition, extra care should be taken when delegating to hosts or Internet Protocol addresses not under an organization's control. Security control. SPF is used to specify authorized email servers, or lack thereof, for all domains. Security control. A hard fail SPF record is used when specifying email servers. Security control. SPF is used to verify the authenticity of incoming emails. Security control. Incoming emails that fail SPF checks are blocked or marked in a manner that is visible to the recipients. Domain keys identified mail. DKIM enables the detection of spoofed email contents. This is achieved by DKIM records specifying the public key used to sign email contents. Specifically, if the signed digest in an email header does not match the signed contents of the email, verification will fail. Security control. DKIM signing is enabled on emails originating from an organization's domains. Security control. DKIM signatures on received emails are verified. Security control. Email distribution list software used by external senders is configured such that it does not break the validity of the sender's DKIM signature. Domain-based message authentication, reporting, and conformance. DMARC enables a domain owner to specify what action receiving email servers should take if they receive emails that fail SPF or DKIM checks. This includes reject, emails are rejected, quarantine, emails are marked as spam, or none, no action is taken. DMARC also provides a reporting feature which enables a domain owner to receive reports on the actions taken by receiving email servers. While this feature does not mitigate malicious emails sent to the domain owner's organization, it can give the domain owner some visibility of attempts by an adversary to spoof their organization's domains. Security control. DMARC records are configured for all domains such that emails are rejected if they fail SPF or DKIM checks. Email content filtering. Content filtering performed on email bodies and attachments provides a defense-in-depth approach to preventing malicious code being introduced into networks. Security control. Email content filtering is implemented for email bodies and attachments. Blocking suspicious emails. Blocking specific types of suspicious emails, such as where the source address uses an internal domain name, reduces the likelihood of phishing emails entering an organization's network. Security control. Emails arriving via an external connection where the source address uses an internal domain name are blocked at the email gateway. Notifications of undeliverable emails. Notifications of undeliverable emails are commonly sent by receiving email servers when emails cannot be delivered, usually because destination addresses are invalid. Due to the common spamming practice of spoofing sender addresses, this often results in a large number of notifications of undeliverable emails being sent to innocent third parties. Sending notifications of undeliverable emails only to senders that can be verified via SPF, or other trusted means, avoids contributing to this problem while allowing legitimate senders to be notified. Security control. Notifications of undeliverable emails are only sent to senders that can be verified via SPF or other trusted means. This is the end of part 11. Please subscribe and like for more content. More parts will continue.